Hey students, welcome to our next video in the series. This time we're going to have a whole lot of videos on covalent bonding, which is our third type of bonding. Remembering we've done ionic bonding and metallic bonding, so now we're going to do covalent bonding. This video is an introduction, and then we're going to look at the first type of covalent substances, covalent molecular substances. So let's go! What are covalent bonds first? Well, covalent bonds are produced when the non-metallic atoms react together. The non-metallic atoms, they're the nonmetals. They're on the right-hand side of the periodic table, to the right of the staircase. Now, they bond together by sharing pairs of electrons, and we'll look at this in more detail. And they're aiming to get 8 electrons in the outer shell by sharing pairs. And remember that 8 electrons in the outer shell, that's what the metals and non-metals in ionic bonding were striving for, so that they could get the electron configuration of the noble gases. So again, we're striving to, the non-metals here are striving to get a noble gas electron configuration, in this case by sharing. These bonds are the result of the force of attraction between the shared electrons and the nucleus. So by sharing electrons they get the negative charges, and then there's a force of attraction between those negative charges and the nucleuses, which carry an overall positive charge. Covalent bonds can be single bonds. Now, a single bond is not one electron, it's a pair of shared electrons. So effectively, one single bond is 2 shared electrons. We must understand that. So you can have single bonds, but you can also have multiple covalent bonds. And those multiple covalent bonds could be double bonds, where there's 2 electron pairs shared between 2 atoms, so effectively 4 electrons. Or triple bonds, where there's 3 electron pairs shared between 2 atoms. So the types of covalent substances we're going to look at through this series of videos are the first ones, which are covalent molecular substances. Some examples are chlorine gas, Cl2, and methane, CH3,4. Again, made up of non-metals, carbon and hydrogen, non-metals. Covalent network lattices. Now, we've mentioned lattices before when we did ionics and metallics, and so that's where you have a regular reoccurring arrangement. You don't have molecules. We have molecules here, but in the covalent network we don't have molecules, we have a lattice, and the lattice is made up of a whole lot of covalent bonds, so a whole lot of sharing of electrons. And the examples here are diamond or SiO2, which is quartz or silica dioxide. And then the other type is the covalent layer lattice, which we've heard of lattices, but we haven't really been introduced to the layer principle yet. And really the main example of that is graphite, and we'll learn about those. So there's our 3 that we're going to go through, and we're going to start with covalent molecular substances first off. So what are covalent molecular substances, you ask? I hear you? Yes. Covalent molecular substances are substances held together by covalent bonds, so those sharing of pairs of electrons, and they include elements and compounds. Elements are things out of the periodic table. The example we used before was chlorine gas, Cl2, or compounds. Now, compounds are when they're made up of more than one element from the periodic table, and we use the example of methane, CH4. But we could also use something like water, H2O. These substances are made up of molecules. And so to be a covalent molecular substance, you've got to have molecules. But what are molecules? I hear you ask again. A molecule is a discrete separate group of non-metallic atoms held together by covalent bonds. So, put that in simple words, we've got a number, usually a small number, but in the real world it can be massive numbers of non-metals, and they're held together by sharing electrons. These atoms are combined in a fixed ratio and are electrically neutral. So there's no charge on a molecule overall. There may be a charge distribution, which is actually outside of the physical science course, but overall the molecule itself is neutral, and one molecule of one substance is identical to another molecule of that same substance. So if you look at one molecule of water, it's exactly the same as another molecule of water. So that we have these recurring units, molecules, of these covalent molecular substances. And they can behave discrete, they're separate, they're not joined together. Okay? So metallic and ionic substances do not form molecules, even though sometimes it's tempting to think that sodium chloride, we're always writing that as NaCl. It might be tempting to think of it as a molecule, a sodium joined to a chlorine, but it doesn't occur. The sodium and the chlorine in sodium chloride, being an ionic substance, is the ratio of the ions in the lattices. So let's not forget that, what we've learnt before. Okay, so it's only covalent molecular substances that occur as molecules. A covalent molecular element, so a covalent molecular substance that's referred to as an element is made up of molecules of the same element. Well, the molecules are made up of the same element. Could say that. Some examples. Monatomic. So here we have helium. It occurs as molecules. Now it's a bit weird chemistry terminology. Like helium occurs as single helium atoms. Is that really a molecule or an atom? The physicist in me says that's just an atom, but the chemist says that's a molecule. It's a monoatomic molecule. Whereas a diatomic molecule, the di suggesting there's two, would be something like chlorine Cl2 minus that we've mentioned before, or O2, oxygen. Okay. Monatomic molecules are composed of single atoms of an element that do not share electrons. So really the only ones that can be monatomic molecules are going to be the noble gases. There you go. Helium, neon, argon, krypton all occur as covalent molecular elements. There's an example. Helium, there's no bond between them. Okay, they're happy. And they're classed in the covalents simply because they're non-metals. Though strictly speaking there's no sharing of electrons. But they occur as molecules. So, diatomic molecules are composed of two atoms of the same element. For example, hydrogen, H2. If we have a look at it, two hydrogens with a covalent bond there, so shared pair of electrons, and they're all discrete, moving around depending on what state it's in. Other examples are oxygen, nitrogen, phosphorus, where there's 4 phosphoruses joined together, sulfur, where there's 8 sulfurs joined together with covalent bonds. They're all called diatomic molecules. Although, strictly speaking, these would be tetraatomic molecules, and that would be a tetraatomic molecule. But we'd class them again in the diatomic molecules again, just to confuse you. So a large number of compounds also exist as molecules, and these are made up of atoms of different elements, which share electrons and therefore have covalent bonds. And I've mentioned a couple before already. These compounds are all called covalent molecular compounds, all substances, but compounds because they contain covalent bonds and they're made up of more than one element. And that's the definition of what a compound is. So there's a little bit of terminology thrown your way, so make sure you get your head around it and you can use it properly in sentences. Water, carbon dioxide, methane are all examples. So H2O, CO2 and CH4 are all examples of covalent molecular compounds. And what's that one? That's going to be carbon dioxide. Carbon is the central atom, then there's covalent bonds between the carbon. There's 2 actually covalent bonds there and there, and there and there between the carbon and the oxygen. And there's 2 oxygens, and every molecule is the same. So in the next video we're actually going to look at these substances in a bit more detail, learn how to draw them and their properties, and so we'll follow on with that. Okie doke.